My name is Matt Shuman. I'm an electrical engineering instructor here at Oregon State University, and I co-teach this class with Dr. Hurst, who is a mechanical engineering professor. So the two of us co-teach this class. We switch lectures, and we organize the course together to make sure that the robotics students get an experience that is balanced between mechanical aspects and electrical aspects. So the interesting thing about this class is we take teams of students from mechanical engineering, computer science, and electrical engineering, put them together, and then have them build a very complex project.
So this is our beer pong robot that we did for the Applied Robotics class at Oregon State. It was a collaborative effort between students of different majors. Taylor was our mechanical engineer, did a lot of the design work for the frame. Phil did a lot of the software work, and I did the electronics hardware work.
This challenge is very open-ended and it's realistic. When they're working on the project, they're working in a basement where there's no sunlight, there's no wind, and when they did their final competition, they did it outside, where they had sunlight, which made their computer vision confused. Also, there was wind, and students didn't know how to deal with the wind. But it's a realistic challenge, and we try to make sure that our students get exposed to real challenges.
We started with, for the class, was a turret-based design, and we started by using laser-cut acrylic and 3D printed parts for the design of it. And so what we can do is we use a LiDAR distance sensor in order to map the distance of the cups, which is the same sensor that the Google streetcars use. After we do that, we can load a ball in, and we use this fan to fire it. We also have this fly swatter sensor. Using a speaker as the microphone, we can detect bounces, and we can block them.
This class is one of my favorite courses to teach because I don't have to think of problems to give my students. I give my students a project, building a beer pong robot, building a checker playing robot, and that open-ended challenge gives them design opportunities where their design creates the problems that they'll face throughout the term.
So one of the main challenges we faced was dealing with turbulent airflow inside of our barrel. So what we did was we created a rotating sleeve that would create a constant geometry, thus preventing the turbulence from developing. And on the rotating sleeve, we created an involute gear. And an involute gear is a gear that follows a certain profile that allows it to have a constant velocity as it's rotating.
Using Python, we were able to make a user interface which allowed us to see the LiDAR data and plot it. So we can actually see the individual cups. We can also plot out the fan speed information. Using the interface, we can tune the robot to fire at various distances away.
So one of the great things about robotics projects in general is that they force you to apply a lot of what you've learned in a theoretical means actually in the real world. And so for this robot in particular, we've had to pull from all sorts of classes, including power electronics, sensors, digital signal processing, SolidWorks, all these classes that oftentimes give you kind of a theory or a general concept. We had to actually apply those in a real working machine. So one of the things that we definitely learned was how challenging it can actually be to take those concepts and apply them into something that will actually work and is a robust system.